Hello, good evening everyone. So today I'm gonna cover the second part of the advanced missing values part 2. First thing first, you need to run all the code cells of this file available on Moodle. We've done the explanation, we went over the explanation of all these cells. I already ran executed, if you want, the cells. So now I have to head all the way down. So last time we talked about clustering in general, and I explained the k-means clustering. Another very similar clustering algorithm is the k-nearest neighbor. Understanding the k-means clustering and clustering in general, as we covered in last class, is very essential for you to understand any other clustering technique. So for k-nearest neighbor, the idea is you specify the neighbors. You want 3 neighbors, 5 neighbors, and so on. And within the number that you specify, the computer will identify the neighbors of a missing value. So for example, the query or the missing value is the rectangular, the green rectangular over here, and these circles are the neighbors. So the algorithm identifies the closest neighbors. The idea is the value of the missing, or the value here for this missing variable or value over here will be closest, more precise, very close to the neighbors, to the points, to the value points, the closest to that missing value. Okay, so where do we get this from? We get this, let's just read first the data frame that we've got. And as you can see, this is the data frame again, before we've done anything with the missing data. And we are going to use a very interesting a class called the KNN Imputer, or the Impute actually, and we import the KNN Imputer. So from the sklearn.impute class, we are going to use the KNN Imputer. So the first thing first, I would like to compare the before and the after. Before the imputation of missing values, when everything looks like this, the df, but I don't want to alter the df. So for the purpose of this class, just for the purpose of me lecturing, I am going to save this data frame in what we call it, I'm going to call it before imputation, just for the sake of class. But for you, if you are working on the quiz, you don't have to do this, but if you want to do it, do it. So as you can see, it's the same, it's same, exact same, but I called it before imputation. So now, and why did I do that? Because it's easier for you to understand the code, all right? So let me show you the code. First thing first, we need to initialize the KNN Imputer. So do you remember that we imported something called KNN Imputer from the sklearn.impute class? Okay, so this is, I'm gonna just call it Imputer. So this Imputer, KNN Imputer, I need to specify the number of neighbors. So I'm gonna take 4 points as the number of neighbors. All right, so now the data frame after imputation will save in it, we will be stored in it the following: the imputation function. And the way that we write this imputation function for the KNN Imputer is nothing but imputer.fit underscore transform, sorry. And then you can transform the, as you can see here, we have a street number, we have the number of bedrooms, and we have own occupied. Now, I probably do not wish to do own occupied for now, but let's do it, and then I will explain why I am a little bit concerned about using unoccupied, but let's run it. So do you understand what I did over here? So what I did over here is I took the df, or before imputation, and I specified here the variables or the columns that I would like to use the KNN imputer for it. Now the output here, I'm sorry, I said that the output is a data frame. In fact, the output here is an array, as you can see here. Sorry. So the output here is an array. You can tell that this is an array because it's, listen, I wasn't really 100% mistaken by saying it's a data frame, because you noticed here there is double lists, double squares. Do you see that? There's this one and there's this one. So this is the array, and this array is containing multiple arrays. This is the first array, and so on. Second array, third array, in rows. So as you can see, this is the outer square brackets are the array, and then there are multiple arrays within the array. And this makes up a data frame, but the output here is not looking good. So I'm gonna just make it as a data frame. I don't know why I did this. In fact, I don't need this line. So the after imputation is nothing but an array. So if you take a look at it, it's an array, and here is the array as you can see it. So for here, this is because I put it as a print function after performing imputation, and then I use the after imputation. But if you take a look at after imputation, you can see that it's an array, and you will see the array as follows. Okay, so I want to convert this array into a data frame. We've done this before. We're going to call upon the pandas pd.dataframe after imputation, and I want the columns to be street name, number of bedrooms, and own occupied. This is important for you to specify the columns when you are converting the array to a data frame. So this is the df imputation, or after imputation, in fact. So df imputation, this is imputed. Okay, you can see now that we have values that are imputed based on the average values, the average of computed using the values of the neighbors. All right, so now as you can see, we have yes and no, but over here we have 0.75, 0.75. So we need to convert this to integers, right? So for own occupied, for example, here we are going to use the data frame of imputation on occupied is the same that as type integer, and now again we got it like that. It's an integer. You want to take a look? Let's take a look. If you want to take a look at the whole data frame, let's take a look at the whole data frame. Now street name is okay. I'm telling to what is it that I'm doing here? I need, okay, there's one thing that I haven't done, in fact, which is over here. I also want to convert this into integer, because there is no 2.5 rooms, right? So I am going to, on occupied is done nicely. So the next step is I got lost all of a sudden. Okay, here is the code. So I am going to use this code to also transform the number of bedrooms. So now we are ready. Okay. Okay. Okay, I've done that already. On occupied. Okay, this is for on occupied. This is for number of bedrooms. It's repetition, this one. Oh, okay, this is the confusion. Okay, so now I have dataset pd.concat. I'm concatenating the df imputation with the street name. Okay, let's see. Let's run this and see it. There's an error. Okay. Street name. Okay. Street name here. Let me check if I can put it as df. Let me try this. Is this gonna work? Yep. So we just, street name is a variable, and always a variable or a column needs to point back to its data frame. So I took it from the df because there's no changes on it, right? There were no missing data on the street name. So here's the street name, here's the street number, bedrooms and all that. This is the data set all cleaned up. Now I would like to compare to you on occupied imputation here with what we've done earlier with the most frequent. If you guys remember the simple imputer, so we worked with the simple imputer in the previous class. In this class we are working with the KNN. So let's take a look here. 1 0 0 0 0. Yes, no, no, no. So more no's here instead of yes. 1 1 0 1 1. 1 1 0 1 1. So there are more no's. Do you see? So I really didn't like the most frequent over here, because the most frequent just gives you the most frequent. The most frequent in all the column was yes. So all the answers were yes. While over here it was more or less kind of following the closest neighbor. So I kind of more keen to using the KNN rather than the simple imputer most frequent. Okay, it's just, you know, I believe that this KNN is more advanced and better. All right, and this is last is save the DF to an Excel file, and then this is it. Of course, you can access the Excel file, the output here, by downloading it, and this is where you are going to submit your quiz. So I'm going to probably ask you to submit the Excel file or your code. If I'm going to ask you to submit your code, there are two ways to submit your code. Well, one way, let's focus on one way. Download as Python B. So please do that, and send and submit it on Moodle, and then I will open the code. Or I might ask you to submit it as a PDF if I want to just open it and see your work. So save as PDF, and then you save it, you put it on desktop. Maybe it's easier for me to just open the PDF and take a look at the code. So here is my PDF. Where is it? What was the name? Sorry, what was the name? Oh man, C Advanced, okay. Okay, so over here also I can ask you to submit the PDF. It's just I don't like the PDF because it's kind of sometimes, yeah, cut off the code. This is my problem with the PDF. This is my problem with the PDF. So it's okay. What can I do? I'm gonna open file one by one. and or I can ask you in fact to copy and paste the code that answers a certain question on a Word document. It's easier for everyone, especially for me. So you can write the code here on a Python file, and then you copy that and paste it as an answer on your Word document. Alright guys, thank you so much for today. Thank you so much for taking the course, and take care of yourself. I'll see you, it's online now, so I won't see you on Friday. I will, we will all have the quiz on Moodle online. So best of luck to everyone, and take care.